Welcome to Brunda Engineering Academy. In this video, we learn about the parallelogram law of forces. It is a basic law in engineering mechanics for both diploma and B.Tech students. Fundamental law. It can be used to calculate the resultant and magnitude of the resultant, and the direction of the resultant force. So, what is the statement of the parallelogram law of forces? This can be used for when two forces are given. When two forces are given, you have to calculate the value of the magnitude of the resultant and the direction of the resultant. So, how can you find out? And what is the relation for the resultant force? And how can you find the direction? In which direction the resultant force will be acting? Okay, and what are the different cases available in the parallelogram law of forces? This entire concept will be discussed in this video. Okay, first of all, let us go for the statement of the parallelogram law of forces. First, I am considering one parallelogram. That parallelogram is O, A, B, C. Like that, I am considering one parallelogram. Now, if you observe the statement, if two concurrent forces means all the forces are concentrated at a single point. So, two concurrent forces, here assume it is the force P and it is the force Q. And these two forces will be acting with an angle of inclination alpha. Okay, these two forces are acting as the adjacent sides of the parallelogram. Then, if two congruent forces are acting as the adjacent sides of the parallelogram, then the resultant force will be the what is the resultant force? Then the resultant force will be the diagonal passing through the parallelogram. Here it is the diagonal passing through the parallelogram. That is the resultant of the two forces. That is the statement of parallelogram law of forces. If two congruent forces acting as the adjacent sides, this is the one adjacent side and it is the another side, then the resultant will be passes through the diagonal passing through that parallelogram. Okay, this is the statement. Now, how can you find out that the magnitude of that resultant force and the direction of that resultant force? First of all, to find out that I will draw a perpendicular line. So this is the perpendicular line to the OA. It is the perpendicular. Perpendicular means it will act the 90 degrees to the horizontal. 90 degrees angle. Now, here the angle of resultant force can be taken as the theta. Assumptions are alpha equal to angle between the forces, angle between forces, whereas theta is the angle of the resultant, angle of resultant force, angle of resultant force. Now I'm here. This is the theta. Then the AC is also having the inclination of alpha. AC will be makes an angle of alpha. Now consider the force here. It is the force Q. Why? Because these two are the parallel sides. OB and AC are the parallel sides. Then that will be equal. From this the basic engineering mechanics, we can write AD equal to Q cos alpha. AD equal to Q cos alpha. Whereas AD equal to Q cos alpha. Whereas DC equal to DC here AD equal to Q cos alpha. It is the term Q cos alpha because horizontal component. Whereas vertical component is Q sin alpha. Vertical component is Q sin alpha. That is nothing but CD equal to CD equal to Q sin alpha. Now I am considering the triangle OCD. That red triangle, that big red triangle OCD. It is a right angle triangle. From the right angle triangle, from the Pythagoras rule, hypotenuse square equal to side square plus side square. What is the hypotenuse? OC. OC square equal to side square. Adjacent side is the OD square plus hypotenuse opposite side is the CD square. From this, OD can be written as OA plus AD. OA plus AD whole square plus CD square. If you observe this diagram, OD can be written as OA plus AD. Then what is OA? That is force P. What is AD? AD means Q cos alpha. Q cos alpha whole square plus CD. CD means what? Q sin alpha. So Q sin alpha whole square. Then we can simply written as P plus Q cos alpha is in the form of A plus B whole square. Then P square plus Q square cos square alpha plus 2PQ cos alpha plus Q square sin square alpha. Q square sin square alpha. If we observe this term, Q square cos square alpha plus Q square sin square alpha, then take the term as a common term. That is the common term. Then we can simply write it as the P square plus Q square into cos square alpha plus sin square alpha plus 2PQ cos alpha. Then from this we can write P square plus Q square. Cos square alpha plus sin square alpha is the 1 plus 2PQ cos alpha. Then here, if you observe this OC square is nothing but resultant force, RC square. Here, this is the OC is the R. That's why I am taking that as R square equal to P square plus Q square plus 2PQ cos alpha. Then R equal to what? Square root of P square plus Q square plus 2PQ cos alpha. It is the magnitude of the resultant force. It is the magnitude of the resultant force. Then coming to the direction. Direction means you have to find out the theta value. You have to find out this value. You have to find out this value. So to find out that value, I am considering the same right angle triangle, but applying the tan theta. What is tan theta? Applying the tan theta for this one. For tan theta. Tan theta means opposite side by adjacent side. Opposite side is what? Opposite side is CD and adjacent side is the OD. Okay. Then consider that same triangle but apply tan theta. Opposite side is the CD. Adjacent side is the OD. What is CD? From that triangle, CD is Q sin alpha. What is OD? OD can be written as OA plus AD. So CD can be written as CD Same as it is. OD can be written as OA plus AD. CD is Q sin alpha. Q sin alpha by OA. OA means force P. AD means Q cos alpha. Q cos alpha. From this relation, we can write tan theta equal to q sin alpha by p plus q cos alpha. Here theta equal to, simply by the conversion, tan inverse of, we can written it as tan inverse of q sin alpha by p plus q cos alpha. So this is the formula for the direction of the resultant force. So these are the important for the competitive examination point of view also. Whereas there is some different cases are there. What are the different cases? Suppose I am considering same thing, r equal to square root of p square plus q square plus 2pq cos alpha, 2pq cos alpha. Then what is, first of all, if the angle between the two, suppose this is the one force and it is one another force. The angle between the two forces P and Q is changes. If the value will be changes, what is the case? If alpha equal to 90 degrees, alpha equal to 90 degrees. 90 degrees means what? That means the two forces are acting perpendicular together. Perpendicular together means it is a horizontal force and it is a vertical force. Then this is the force P and it is the force P. Here the angle between the two forces is alpha equal to 90 degrees. Then what will happen? Then R equal to square root of P square plus Q square plus 2pq cos 90. What is the value of cos 90 degrees? Cos 90 is 0. Then simply r equal to, the term will becomes p square plus q square. In the gate point of view also, in gate exam point of view also, if they may be asked the different cases. If alpha equal to 90 degrees, then determine the magnitude of the resultant force in this manner. Suppose the case 2, if alpha equal to 0 degrees, or if alpha equal to 0 degrees, then what will happen? Then r equal to p square plus q square plus 2pq cos 0 degrees, 2pq cos 0 degrees, cos 0. Then what will cos 0 value is 1. Then we get r equal to square root of p square plus q square plus 2pq. Cos 0 value is already 1 in this way. Whereas if alpha equal to 180 degrees, what is the case? Alpha equal to 180 degrees. Then r equal to square root of p square plus q square plus 2pq cos 180 degrees. Then what is the case? Cos 180 value is what? Cos 180 value is -1. Then the value becomes p square plus q square. It is the value of minus 2pq. So if you observe these three cases, which value is higher? Then what is the when magnitude will be maximum? Suppose if you observe this is r equal to p square plus q square. Okay, this one. And here r equal to square root of p square plus q square plus 2pq. Okay, if for alpha equal to 180 degrees, that value is p square plus q square minus 2pq. Here the magnitude will be the maximum. Yet alpha equal to 0 degrees. Whereas magnitude will be the minimum. Magnitude of the resultant force will be the minimum. Yet alpha equal to 180 degrees. 180 degrees. So in this way, they may ask the question. In for the JNTU Kakinada syllabus also, This way, this derivation can be helpful. You can remember for the competitive examination point of view. For the competitive examination point of view, you can remember this entire concept like this. The statement: if the two concurrent forces are acting as the adjacent sides of the parallelogram, then the resultant force will be the diagonal of passing through that parallelogram. And finally, the formula: the magnitude of the resultant force is R equal to P square plus Q square plus 2PQ cos alpha, whereas magnitude direction is theta equal to tan inverse of Q sin alpha by P plus Q cos alpha. The three different cases: when alpha equal to 90 degrees, then R equal to square root of P square plus Q square. If alpha equal to 0 degrees, then the magnitude equal to P square plus square root of P square plus Q square plus 2PQ. That will be the maximum magnitude. Whereas alpha equal to 180 degrees, the magnitude will be the minimum. Okay, R equal to square root of P square plus Q square minus 2PQ. Okay, in the next video, how we can find out the problems by using the parallelogram. We can solve the problems by using the parallelogram law of forces. If you have any doubts or any feedback, you can mention in the comment box. Okay, then I can easily reply to you. And thank you.